is Uwe. I'm taking care of DC to DC converters with a low input voltage in industrial systems. Today, we would like to give you a few examples of newly available products that covers, for example, the core supply of a processor or FPGA that may benefit from so-called dynamic voltage scaling. We will also look at new parts for more point of load kind of solutions in leaded, easy to use SOT packages. Then we will look at the new parts with the forced PWM as an option. And as you know, forced PWM can give you a lower output voltage ripple. And last but not least, we will have a quick look at some of our newest modules. So that means having a DC to DC with an integrated inductor, which is of course easy to use then and a small solution. Before we go into these product examples, let's have a quick general view on this topic here. Especially wanted to show what we mean when we talk about low input voltage. A very generic power tree here. On the left-hand side, you have the source. It can be a line power, it can be a battery powered. And on the right-hand side, you have the different kind of loads in your systems. And what we typically see, of course, is when you have a wider input voltage, you go by a two-step approach to first an intermediate rail, and then from there, which can be 5 volt, can be 3.3 volt. Of course, you have the options to use either linear regulator, integrated PMIC, or different types of buck converters. Or if you're going from a battery or USB or other already regulated supply, then you can also go directly to a low voltage buck converter or a buck boost or a boost converter to your load. So these are the things that we are talking about today, low input voltage buck converters. Now, we see a couple of trends and solutions in this market worldwide. For example, for all the digital world, because of the semiconductor process geometry is getting smaller and smaller in the digital world, we see that the supply voltage of these kind of loads are getting lower and lower. So what may have been 5 volt or 3.3 volt in the past, of course, this is now 1.8, 1.2, or even below 1 volt supply for the core of these digital systems. With that comes, of course, some changes also in the power supply, because many of these processors and FPGAs are specified, for example, with a 5% or a 3% accuracy requirements of their supply rails. And, having 5% of 1 volt supply, you just have 50 millivolts with all the changes on low transient and ripple on that. So this, of course, requires then that the buck converter, as an example, needs to be also having a higher accuracy. And that's, for example, one of the reasons why most of our newly released products here from Texas Instruments are specified at the 1% accuracy over the full temperature range. And this is also important because when you look at different kinds of solutions on the market, you often see 1% on the first page of the datasheet. But in TI, we also carry that into the parametric tables to having this high accuracy over the full specified temperature range. Another option, of course, having a fixed output voltage version, because then you have the accuracy not only at the feedback pin, but really at the output rail. Coming with the lower supply voltages, coming often a higher current. So we see a trend also that many of these digital world parts, process FPGA, require higher current than in the past. And that means the transient response need to be much faster maybe than in the past. So we have specifically control topology to cope with that. And what we also see that more and more of these systems can benefit from a dynamic voltage scaling, so changing the supply voltage during operation. Here an I2C interface can help, or a select pins where you can toggle between different output voltages. Now, besides the core voltage, there are multiple other rails for the memory, for the IOs, and for interface or whatever. So you see very often multiple supply rails in your systems. And here, a pin-compatible family approach can be of benefit, because then you just have one layout, one solution, and depending on the current needs, can be a 1 amp, 2 amp, 3 amp, or whatever, you can just exchange very easily between whatever you need in your current system here. But because of this multiple supply rails, often a sequencing is maybe required. So PowerGood could be an example of the solution here, but sometimes you need even more accurate sequencing. So we have also functionality integrated in some of our buck converters to support that. With all these higher currents, multiple supply rails, thermal performance could be becoming more and more a challenge. So high efficiency is really very often required. And with that comes, of course, then package questions to cope with this. On the other hand side, it needs to be small, because typically your board is not getting bigger, but you may need to add functionality on your board. So small packages important, but especially having also small and few external components to cope with that density requirement. And in some cases, of course, you need to have a very quiet supply, maybe ask for a fixed frequency that can be synchronized to an external clock, or having a force PWM, or even a SPED spectrum. And last but not least, just wanted to mention again the trend, the very strong trend that we see towards modules. And modules is when, as I said before, the integrated inductor, or even sometimes integrating also some capacitors. This gives you, of course, small solution, but it also really makes it easy for you, because these are tested solutions ready to use. So you can have an advantage in time to market here. Now, because of this different kind of trends, just let me see here. Let's see here, a technical error. So I hope you can see it again, sorry. So because of the different trends that we see in these markets, there's not only a single device that can help you here, it's really a portfolio that is needed. And you just give you here a view on the new product highlights. There are many more parts available, of course. So we will look at some of these devices. From this page here, some of these devices have a different color. So it's a kind of light teal, light blue. Those are, you can find them on the internet, but they may not yet be in full production. But they are listed here because we have already samples and evaluation modules and data sheets for you available on the web. So let's start with the first example here. And this is about a core supply with either 4 amp or 6 amp current. The TPS 62868 and 869, these have the dynamic voltage scaling through the I2C interface that was mentioned. And you can see from the output voltage range from 0.4 to 1.675, this is really made for the core supply. And you can change these output voltage in 5 millivolt steps. It does have a control topology to have a very fast transient response. We call this a DCS control, direct control, and seamless transition to low power mode. And this gives you the fast transient response and a very low ripple transition to the low power mode. As you can see, these have a very low RDS on, which gives you the good high efficiency that you may want, but it also enables this kind of up to 6 amp output current to become available in a very small package. So it's either 1.5 by 2.5 millimeter and just 1 millimeter height QFN, or even smaller chip scale packages. Now, through the I2C interface, you have, of course, a lot of flexibility built in. You can not only change the output voltage dynamically, but you can also select if you want to have the low output ripple force PWM mode or a power save mode. You can change the ramp speed of the output voltage. You can change if you want to have an automatic output discharge or not. And it also gives you a thermal pre-warning. So of course, these kind of buck converters are thermally protected, but you typically do not want to have the thermal protection shutting off your power supply. So this system here gives you already a pre-warning. And with that, you can, for example, start a fan or, reduce the frequency of your processor or anything else. Besides the I2C, there's another flexibility through the VSAT VID pin. And this here helps you to have a single device for multiple projects. That means with the same device, you can set different I2C addresses, and you can set the startup voltage. In the past, typically it was required to have different devices for different startup voltages, but now you have a single device and you can set the startup voltage here. It's not a single device, it's a complete family with different options that you have here. The left-hand side, you can see here what I mentioned before, 0.4 volt to 1.675 volt output rail in either QFN or chip scale package. And you can see there's an A version and a C version with either a power good and I2C or the VID pin and I2C. And you also see on the right-hand side other versions that have different output rails. And all these are already mentioned in the datasheet that you find on TI.com. And I wanted to highlight here the version that is marked for LPDDR5 memory. So the new specification for this next generation memory, low power memory, that is specified down to 0.3 supply volt. So again, you can use these dynamic voltage scaling to really take advantage of the low power within LPDDR5, because you can change it dynamically in a low power mode for the memory, and the buck converter even supports this low power mode here with this dynamic voltage scaling. Now let's look at the different kind of example here for buck converters. And this is more a kind of point of load solutions with 500 milliamp, 1 amp or 2 amp. And the specific thing I want to mention here is the package. It's a leaded package, but very small. Now, of course, you know the SOT23, but the SOT583 comes in a much smaller solution size here, as you can see. But it's still a leaded package, and that means, for example, it may be preferred by some people on the bench because you can access it during the development phase, the access the pins, but also in mass production, because here you can have a visual inspection with the camera, for example, compared to a more expensive X-ray system that you may need for a chip scale package or QFN. So here the pins are accessible and can be inspected automatically by a camera system. So here again we have, as mentioned before, the 1% accuracy from -40 to 150 degree junction. You can synchronize the frequency from 1.8 to 4 megahertz, and you can also switch between the forced PWM mode with the low output ripple or a power save mode. So you have here pins available for the mode selection, and you have a pin available that you can either use for an adjustable soft start. So with an external capacitor, you can change here the soft start timing. And if you prefer a different functionality here, there are also on the right-hand side versions available with so-called selectable compensation. Now the compensation for this one is still internal. So you don't need to calculate any kind of Excel sheets, whatever, for the compensation. It's internally, as for the other ones, but you can select between different compensation networks, depending, for example, on the output capacitance, on the load capacitance you need to power. So it's again a family, as I mentioned, pin-to-pin compatible, 500 milli, 1 amp and 2 amp, and we're also looking at higher current versions later this year. Now, one additional point I wanted to make here on this family as an example is that these are also classified as functional safety capable. And that means documentation is available for you on TI.com on fit rate, failure mode distribution, pin FMA. So if for some of your systems you may need to work on a functional safety capability of your system, these parts may be able to help you, and the documentation is available to support you here. The next example here in this range is something specifically for forced PWM versions. So it's again a family. All these are family approaches. In this case, 1 amp, 2 amp, 3 amp, 4 amp pin-to-pin compatible. So the TPS62820 series already in production with a very low RDS(on), and that means for you a very high efficiency across a wide load range here. It's again 1% accuracy, -40 to 125 TI junction. It again uses the DCS control that where you can benefit from the very fast transient response, very low quiescent current in case your system is battery powered, and again small external components, and the total thing is packaged in a 1.5 by 1.5 millimeter QFN, so very small package and solution size here. And it's available as a module as well with integrated induction, and I will come to that in a minute. Now this family is now available also with the forced PWM version. So it's pin-to-pin compatible, 1 amp, 2 amp, 3 amp, 4 amp with automatic power save mode or a forced PWM mode. Again, the forced PWM mode helps you with some lower output voltage ripple. We can see that here, which took from the datasheet. On the left-hand side, you see this family here with the automatic power save mode. And of course, in automatic power save mode, you only switch it sometimes. And this is here on the lower end of the graph here. Just sometimes you need to switch to get the output voltage stable. But of course, that creates a little bit of a ripple on the output voltage. It's not much. You can see here around 10 millivolt for 100 milliamp output, but still, it's still sometimes required to have an even lower output ripple. And therefore, on the right-hand side, you now have the option to use the same device basically, but with a forced PWM mode. And you can see here the output ripple is really going even lower than before. So you have now the option to either using with or without the power save mode, and it's a family 1 amp, 2 amp, 3 amp, 4 amp in a very small package. And this is a family that is also available as a module. And module means here, for in this case, an integrated inductor. So it's a TPS-M, M for module, 82820 series. The module overall is just 2 by 2.5 millimeter, very small, and just 1 millimeter height, including the inductor. So we have available here now 1 amp and 2 amp and 3 amp is coming. You still have the 1% accuracy over the full temperature range. You still have the good efficiency, the low quiescent current. You still have the DCS control for fast transient response and the low ripple that I mentioned before. But as an easy to use module that really can be placed wherever you have a little bit of space on your board really closely locally to your load, and that makes it really easy for you. It's a tested solution. If you need a little bit more current, then on the right-hand side, you have 3 amp and 4 amp versions, but with a different kind of control topology. So the TPS M82810 series, it uses a peak current mode control with a fixed frequency. Now you can change the frequency, but it's a fixed frequency between 1.8 and 4 megahertz, and you can synchronize this switching frequency to external components. You can select between a forced PWM mode or a power save mode. Again, something that I mentioned before, you can select between different type of internal compensation networks, so adapting this to the load capacitance you need to support. You can change the soft start timing with an external capacitor. You can have a very accurate tracking for sequencing if required. And the same device is also available with a spectrum as an optional solution for you. So some people prefer the spectrum, so these modules are available with or without this spectrum feature. Now these kind of modules here, just to show you how and what we're doing here, see here a cross-section of this, what we call an embedded DC to DC converter module. And you can see the DC to DC, the silicon, what is called here the PicoStar, is embedded into a PCB board, and the inductor is on top of that. And that may basically make the DC to DC converter a zero size because it's below the inductor. So it's a very, very small solution size, but still you can use your standard reflow manufacturing for this. So if you can use QFN packages, you can use this kind of packages. But because of the very, very short distance between the switching element, the DC to DC, and the inductor, you have a superior EMI or noise performance. It cannot basically get closer together than this here. This kind of system in package integrates the IC in the laminate substrate and the external components on top of that. It's really in high volume production since now 10 years now. So it's really a mature manufacturing at Texas Instruments. And we have a lot of customers in industrial areas that are using this already. It's a very strong trend that we see that more and more people are looking at this kind of easy to use solutions, which are small and have all the technical benefits of the things that I mentioned before. So just to wrap up here, we talked about some examples of new products. I put here together all these TPS 62800 series that are new in our portfolio. This goes from very, very small solution size in chip scale package, which are really the smallest that we have in our portfolio. It goes to automotive qualified families from 1 amp to 4 amp. And then we talked about the news in the 62820 series with a very low RDS on, that means very high efficiency, that is now available with or without power forced PWM from 1 amp, 2 amp, 3 amp, 4 amp. There's also a family for more battery powered systems. You can see here the 840 series, where the quiescent current is specified down to 16 nanoamp, and this is the operating quiescent current, right? For if you need to extend the battery runtime of your system. We talked about the 850 series in these SOT 583 leaded packages for more point of load kind of systems. That is, you have either forced PWM or power save mode. It's a fixed frequency with where you can synchronize the switching frequency. And that are, if you remember, the functional safety capable. Then the 860 series we started with as for the core supply that offers you the dynamic voltage scaling. So this, we talked about the 6 amp and 4 amp, but there are also versions with just 1 amp or 600 milliamp if that is needed here. And last but not least, we mentioned these easy to use and small modules with integrated inductors as well. And basically that's what I wanted to show you today about our new products from Texas Instruments with low input voltage buck DC-to-DC converters. Thank you very much.
Thank you, and thank you everybody for attending today. Our next topic will be next Thursday, and the topic would be stepper motors. So please join the link that's on the screen right now to go check out the PDF version of the slides and the archived recording at the end of the day today. And then we hope to see you next Thursday for our next topic. Have a great week, everybody.